All right, let's see what happens when we're trying to find all the zeros of a function with degree 4. Okay, it's going to be the same process. We're just going to have to do synthetic division twice instead of once. Okay, so let's list out all of our possible rational zeros. Remember, it's going to be plus or minus the factors of our constant divided by the positive and negative factors of our leading coefficient. Okay, so factors of 5 are 1 and 5. We're going to do a synthetic division process, but to make it go a little bit quicker for us, I am totally fine if you take a look at your graph. Okay, 41x to the third, 42x squared, minus x minus 7. Okay, and then see we have a lot of x-intercepts to choose from. I'm going to choose those nice integers, -1, -7. I'm going to start with -1. Okay, we're going to do synthetic division. 5, 41, 42, -1, -7. Okay, and then follow your process. All right, and then here, right, we have a constant x term, x squared, x cubed term. So we could try to factor by grouping using that polynomial, but it doesn't always work. Factoring by grouping only works sometimes. It's actually not going to work in this case. So what we need to do instead is do another iteration of synthetic division. Okay, so we already know from that first round that x equals -1 is a root. Okay, let's go back to our graph and find another integer root, -7, and do synthetic division with that one. Okay, follow your process. Let's see. We get a remainder of 0, and so we know that x equals -7. We know that's one of our roots, and then here now we have our constant x in our x squared term. And so we can solve this using the quadratic formula, factoring, or completing the square. Okay, I'm going to complete the square. Okay, so 5 is our a value, 1 is b, -1 is our c value, so x is going to equal -b, so -1 plus or minus the square root of b squared minus 4 times a times c, all over 2a, which is going to give us 10. Okay, so -1 plus or minus the square root of 21 over 10. All right, and I'm fine with you just leaving it there because this plus or minus represents 2 roots. And there you go. Not too bad. All right, pause the video. Try this one on your own. Start by listing out your possible rational zeros just for the sake of being consistent. Okay, so 1, 7, 1/3, or 7/3 could be zeros. So what we are going to do is take a look at our graph, right? 3x to the 4th plus 22x to the 3rd plus 6x squared minus 6x plus 7, and so we see 2 real zeros, -1 and -7 again somehow. So let's do synthetic division. 3, 22, 6, -6, and 7. Not over in here. Okay, carry down, multiply outside, add inside. All right, and then go back to your graph, find that other integer 0, which is at -7. So we're just going to set up another synthetic division right here. Okay. There we go. And then now we're left with, so we already determined that x equals -1 and x equals -7. were 2 of our zeros, and then what's unique about this function is that there are no other x-intercepts, so that tells us the other 2 roots are going to be imaginary. So we're going to need to use the quadratic formula or computing the square here, right? Constant x squared term. So a, b, and c. X equals -2, so negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which would be 6. Okay, clean it up a little bit. Inside that radical, we're going to end up with a -8. And so that tells us we're going to need to move into imaginary land, just like I recommended, or just like I predicted. Okay, this becomes I root 8 over 6, which becomes 2 plus or minus 2I root 2, because this 8 becomes, remember, it becomes root 4 times root 2, which becomes 2 root 2. Okay, so that's where I got that 2 from. And then we're over 6. We're going to simplify, right? We're going to divide everything by 2 that we can. So we'll end up with 1 plus or minus I root 2 over 3. Okay, this 2 is stuck underneath the radical. It will not be divided by 2. It's going to stay the same. But this 2 and this 2 and the 6, they will all be divided by 2. Okay, so x equals 1 plus or minus I root 2 over 3. So now we have all of our zeros of this function. We are done. Look at your practice. Let me know what questions you have.